In our last activity, which involved Desmos, you were introduced to the idea of slope ratios and slope angles. So for example, we looked at a ratio of 1/5, and a slope ratio of 1/5 gave us an angle measurement of about 11 degrees. And we looked at 18 degree, which ratio is about 1/3, a 22-degree angle, the ratio is about 2/5, and the last one we looked at was a 45-degree angle, and that ratio was 1. All of them, the 45-degree angle was the only one that was an exact answer. All the other ones are an approximate answer. So we're going to extend that idea of slope ratio to our first of 3 trig rules. You will need a calculator for the remainder of our work with trigonometry. So we're going to start with the first rule today and finish it up on Thursday. And then next week on Monday, Wednesday, we'll look at the last 2 rules, and then with an assessment on Friday of next week. If you don't have a calculator, you would go to your Desmos account, and if you click on the scientific calculator, when you do that, this will be the calculator that will show up. Now, if you have your own calculator, I'm going to give you a check that needs to be done each time you pick up your calculator, just to make sure that you are in the right mode, because there are actually 3 different modes you can set your calculator at. And for the first rule, which was actually a tangent rule, you can get 3 different answers. And only one of them is going to be the right answer for the problems we're doing. So the function we're going to be using is called tangent, which is abbreviated as TAN. And the tangent of 45 degrees, you should get an answer of 1. So this kind of goes back to the problem we did last week when we did the 45-degree angle. The ratio was 1 to 1 because the 2 sides were actually the same length. And that's what the answer of 1 is telling us here, is that for a 45-degree right triangle, the rise and run ratio will have a value of 1. But if you are not in degrees, for example, this one here is set at degrees. If you're not in degrees, but if it's set at radians, which is a different type of measurement, you'll get an answer of about 1.619. And the other one's called gradians, and which doesn't show up a lot of calculators today, but some of the older calculators have that, and it comes up to be like 0.86. You want to make sure that your setting is in degrees. So always check your calculator, make sure you get tangent of 45 equals to 1, going back to our ratio from last week. So in doing trig problems, I'm going to give you what I consider to be the best approach, and I've been teaching trig now to students all the way down to 7th grade for the last 20-some years, and I've just found that this approach has always worked best. I know for some of you that the idea of shading isn't something that you may want to do to begin with, but you may find it to be the best way to keep everything organized. At some point you may find the shading is not necessary. But I'm going to talk about the idea of shading an angle and then marking sides based on that shading. So the angle that I'm going to be using is called theta. And if I would shade the 2 sides of angle theta, the side that doesn't get shaded is called the opposite side. The side that's opposite the right angle is the hypotenuse. And then the third side is called the adjacent side. So when I go through problems in class, or as I discuss things on the video, I will always go in this order. I will identify the opposite side first, hypotenuse second, and then the third side is always called the adjacent side. So the rule we're going to be talking about again is tangent. So your calculator will abbreviate that as TAN. And the tangent of our angle is going to be equal to the ratio of the opposite side over the adjacent side. So we do not use hypotenuse at all for this rule. So like the calculator problem, the tangent of 45 degrees was 1. That meant that the opposite side and the adjacent side were both the same number. And from last week's problem, when we looked at slope triangle, the rise and run were the same numbers, so it was an isosceles right triangle. So we're going to do 3 screens of problems, and in each screen I am asking you to identify which of these triangles uses the tangent rule, because there are 3 rules, and we're going to talk about tangent for today. So what I'd like you to do is to shade the 2 sides of the angle that's given to you, that's the non-right angle, and then identify the sides as opposite, hypotenuse, adjacent, and then circle the triangle that will use the tangent rule, which is the hypotenuse, which is the opposite side and the adjacent side. When you're finished, turn the video back on. I would encourage you to do all 3 problems on this screen, and if you feel comfortable with your answers, move on to the next 2 screens and complete those problems. If you don't feel comfortable, you just want to kind of check, then just turn the video back on and check the first problem, and then continue on to the other 2 pages. So to save a little bit of time, I went ahead and shaded the 2 sides of the angle. So for the 50.1 degree angle, I've shaded AC and AB. So side CB, or X, is the opposite side. The side that's opposite the right angle is the hypotenuse, and the third side is the adjacent. So I'm going to use this abbreviation for opposite, hypotenuse, and adjacent. If you want to use HO and A, that's fine. For the bottom left triangle, the side that's not marked, which is the opposite side. The side opposite of the right angle is the hypotenuse, and then the third side is the adjacent side. The last one, the AC, or 10.8, that's the opposite side. Again, the opposite side is the side that's not shaded when you shade the 2 sides of the angle. The side opposite the right angle is the hypotenuse, and then the third side is the adjacent side. So as I mentioned, that you're trying to identify which of these triangles is the tangent problem. So in this problem here, the first triangle at the top, we're using 5 for the adjacent. The hypotenuse is the length of X. We're not using the hypotenuse. This is a tangent problem because we're using only the adjacent opposite side. In the second problem, we're using the hypotenuse and the adjacent side. We're not using opposite. This is not a tangent problem because we're not using the opposite side. In the last problem here, we're using the opposite and the hypotenuse. We're not using the adjacent. And again, this is not a tangent problem because we're not using the adjacent side. So this problem here, hopefully, is the one that you looked. So in this problem, or set of problems, we're given the angle measurement, which again, I'm going to keep calling that angle theta, and we're looking for a missing side. Sometimes, like in the next screen, sometimes the angle measurement is not given and you're actually given the 2 sides. But identifying which problem is the tangent problem is the same steps. So it doesn't matter whether I'm missing a side length or if I'm missing the angle measurement. Identifying the opposite, adjacent, hypotenuse, that process is the same. So for the top triangle here, this would be the opposite side, since that side did not get shaded. The side opposite the right angle is the hypotenuse. The third side is the adjacent side. In the bottom left, the side that did not get shaded by the 2 sides of the theta angle is the opposite side. The side opposite the right angle is the hypotenuse, and the third side is the adjacent side. The third one, again, side that's not shaded is the opposite side. Hypotenuse opposite the right angle. The third side is the adjacent side. So for the top triangle, we are using the adjacent side and the opposite side. We're not using the hypotenuse. This problem here is a tangent problem. For the bottom left triangle, we're using the adjacent and the opposite side here. So that makes this problem another example of tangent. Again, those are the two sides we're using. And for the third problem, we're using the adjacent side and the hypotenuse. We're not using the opposite side. This is not a tangent problem because we're not using the opposite side. So the top triangle, I've already identified I've already shaded the two sides at a 47-degree angle. The side didn't get shaded is opposite. The side opposite the right angle is the hypotenuse. The third side is the adjacent side. Bottom triangle, the x side is the opposite side. The side opposite the right angle is the hypotenuse. And the last side is the adjacent side. And the last one, 4, which the side did not get shaded, that is the opposite side. AB is the hypotenuse, this is opposite the right angle, and the last side is the adjacent side. So on the top triangle, we're doing the hypotenuse, and we're using the adjacent side because they got an x and a 3 there. We're not using the opposites. This is not an example of tangent. For the bottom left triangle, we're using the hypotenuse, and the x is the opposite side. We're not using adjacent. This is not an example of tangent. We're not using the adjacent side. The last one, the 4 is the opposite side. The x is the adjacent side. We are not using the hypotenuse. This one here is an example of tangent because we're using the opposite and the adjacent side. This will be the end of the first video because the videos are maxed out 15 minutes and we're about 12 minutes now. The second video, we're going to be looking at some problems. We're trying to find the missing side using tangent, and then there are some homework problems that will be at the end of the second video.